Hi everybody, this is Eric Tremblay. This is my VM812 final project, and I'm doing it on the subject of lactose. Now, you folks are already probably pretty familiar with lactose, and you know that it's common in the North American diet, and the biggest source of lactose in that diet belongs to this culprit. Yes, the common dairy cow. We eat a lot of dairy here in North America, and so the natural sugar lactose is found in these products, and so that extends all the way to cheeses, to yogurts, to things like sour cream. Okay, let's take a second to look at how prevalent lactose intolerance actually is. So I made this table here. So starting at the top, South America and Africa, Asia, it's very prevalent there. In fact, in many of those countries, the incidence of lactose intolerance is over 50%. If we gravitate now to North America and we talk about the USA, many studies have been done in the USA, and they've noticed that it varies basically based on cultural background, what kind of incidence is present in the population. 15% of Caucasians seem to be lactose intolerant to some degree, where about 54% of Latin Americans are lactose intolerant, and 80% of African American individuals are lactose intolerant. So in Canada, it's about 16% is what the studies show. In Australia, it's only 6%, so it's a very small amount in Australia, and it's in the same neighborhood over there in New Zealand at 9%. And then I was able to find some statistics from India, and it varies quite a bit in India. Of course, India has a large population, so some regional differences are to be expected. And I saw that some regions were reporting as high as 66% lactose intolerance, whereas other regions were down much lower, near 27%. So what the literature shows us is that lactose intolerance is in fact very prevalent, and so it's important for us to understand how to find lactose in the products that we eat. Also, many processed foods can be prepared with lactose as an ingredient, so you always have to take time to check the labels and read the labels carefully. Now in my house I have a couple of small boys, and we've eaten our fair share of Eggo waffles, so I chose this particular label to show you right now. So you're familiar with these labels. You know that they have got an ingredients panel right here. Now if you take a moment and quickly read through the panel, you can also pause this video and read through it a little if you need more time, but you'll see it doesn't say anywhere on here lactose. Instead, you have to draw your eye to this panel below it, and it says contains wheat, egg, milk, and soy ingredients. And this is your big tip-off when you see milk that lactose is probably present in this particular product. So now I'm going to take a moment to talk to you about the molecular nature of lactose and how it works, but first I have to refresh your memory on monosaccharides. So here are two common monosaccharides. Here's glucose on the right, galactose on the left. You see these particular molecules, when you see them side by side, are very, very similar. Okay, the only differentiating factor right here is this hydroxyl group. Okay, they're both 6 carbon chains, and you can count out the carbons right here. If I do it with glucose, 1, 2, 3, 4, 5, and the 6th one is right up here. So they both are 6 carbon chains. Now it turns out that these two particular monosaccharides, when you link them together with a beta-1,4 glycosidic bond, you form the molecule lactose. Okay, so there's no real magic here. It just you can see that how this disaccharide is formed from these two particular monosaccharides. So now I'll take a moment to tell you a little bit about how lactose is metabolized in the normal individual. Okay, so right here I have a micrograph that represents the interior of the small intestine, and then I'll just orient you to a couple of things here. Right here is the villi. That's, for example, one villi, and then beside it is another villi. And then each of these villi structures is lined with epithelial cells. So the epithelial cells are right here on the outer surface. They're adjacent to the lumen. Here's the lumen, of course, of your small intestine. Now on the apical surface of the epithelial cells are the microvilli. They're sometimes called the brush border. So let me illustrate on the next slide what that might mean with a little illustration. So here again we've got the lumen on the left side, so that represents the left side, And then here's a close-up of one epithelial cell, for example. And this is the microvilli here, and what we call the brush border. So you can see there's that little folding. So I'll just highlight here in yellow, again, what I mean by the microvilli and the brush border. Okay, now let's head back to the micrograph and talk about lactose. And now if I bring in a little cartoon representation of the disaccharide lactose, where one of these colored ovals would be glucose and the other one would be galactose, then you can imagine that entering into the gut. So it turns out that in the brush border of the small intestine is an enzyme called lactase. And the job of lactase is to hydrolyze this molecule of lactose into its two constituents. So it liberates these two particular monomers. And now these particular monomers, when they're found in the small intestines, can be absorbed into the epithelial layer and inside into the gut. These monosaccharides are easily absorbed into the villi via active transport mechanism using sodium-dependent glucose transporters. They're called SGLUT1 or SGLUT1, and they're found on the apical surface of the epithelial cells. Okay, so let's switch back to the illustration now so I can show you a little bit about the active transport mechanism. Here's our lumen on the left-hand side and brush border, and let's propose now that a molecule of glucose is found here in the lumen, and it can be either glucose or galactose. It's the same process here. They're both 6-carbon sugars, as I mentioned to you before, and the same transporter works on them. Now the active transporter is called SGLUT1. It's found here on the apical surface of the epithelial cells, and it's a co-transporter, so it actually needs a molecule of sodium in order to function, and together these two molecules will cross across the cell membrane using active transport and bring these molecules into the cytoplasm of the cell. Now in the case of glucose, it doesn't remain here. It actually gets transported to our bloodstream, so it has to leave this epithelial layer, and there's another receptor that comes into play to make this happen, and it's called GLUT2 receptor. It's the GLUT2 receptor, and it's not, unlike SGLUT1, it's not a co-transporter. Glucose all by itself makes it through this active transport mechanism using this particular specific transporter. Okay, let's head back to our micrograph. So as long as that lactase enzyme is present, then lactose can be broken down and absorbed efficiently into the epithelial cells. So what I've just described there is the normal process that happens in the normal gut, but there are individuals out there that are actually lactose intolerant, and in their case it's a little different. In their case, what happens is that sure, lactose reaches the small intestine, but these lactose intolerant individuals usually are deficient in the lactase enzyme. So with when lactase is not found inside the GI tract, then what will happen is you won't get metabolism of this disaccharide. So this disaccharide basically passes through the small intestine relatively unchanged. Then it moves to the next part of our digestive system, which is called the colon or the large intestine. So here's another micrograph illustrating this part of the organ. I'll situate it to you right now. At the very bottom here, at the very bottom in the right-hand side, or excuse me, left-hand side, is the muscle layer. It's a muscle. Then you've got a connective tissue layer, which is sandwiched in the middle here. And at the top is the epithelial cells. These are the epithelial cells that are adjacent to the lumen. So up here, this white section is the lumen. And there's our little cartoon diagram illustrating lactose. So what I'm going to do now is I'm just going to push this micrograph down just a little bit to give us a little bit more room to talk about what happens when lactose reaches the colon. So the first thing that happens is that the large quantity of lactose, when it does find itself into the large intestine, starts to disrupt the osmotic pressure in the lumen. And what happens is that you get a water influx. So water will enter into the large intestine, and that in itself has a very undesirable effect, because what it does is produce loose stools. But for individuals that are lactose intolerant, it doesn't stop there. The natural flora that's of course found in your colon will has the ability to metabolize lactose as well. So here's an illustration of bacteria that using an enzyme called beta-galactosidase will actually metabolize lactose into its two monomers, those monosaccharides of galactose and glucose. And it doesn't stop there either. Further, bacteria can use these particular monosaccharides as fuel in fermentation, and then some bacteria will indeed produce small metabolites as well as evolve some hydrogen gas. It continues on from there that there's actually bacteria in your gut that will use that hydrogen gas as fuel, and they make methane. So now you've got a situation where not only do you have some small metabolites that are soluble, but you've also got some gas buildup here in the form of hydrogen and methane. And this causes a lot of bloating in individuals that are affected, and a lot of gas and some cramps and general discomfort. So combined with the loose stools, this becomes an extremely undesirable concoction of symptoms. Now, fortunately, there's good treatments for lactose intolerance, and I'll just talk about a couple of them now. The first thing that you can do if you find yourself lactose intolerant is you can just avoid lactose. Okay, and here's a picture here from lactose-free milk. And this is basically normal milk that's been treated with exogenous lactase enzyme at the processing plant. And that way, if you ingest it with no lactose present, you won't have any symptoms. So what's interesting to note too is that this particular type of milk, lactose-free milk, sometimes tastes a little sweeter to some individuals, and the reason is because it's been treated with the lactase enzyme at the processing stage. There's an elevated amount of glucose and galactose, right? Those free monosaccharide monomers are still present in the solution. So that's where the sweeter taste than conventional milk can be detected. Of course, you can just avoid dairy altogether. If you avoid dairy, cut dairy products out of your diet, then no symptoms will occur. You'll be completely asymptomatic. And of course, one way to do that is also you can use milk-like products in your diet, but milk-like products that are lactose-free, like soy milk, rice milk, almond milk, coconut milk, for example. Now, if you're the kind of person that is lactose intolerant, but you don't want to remove actual dairy products from your diet, have you got any other choices? Yes, you do. You can instead add the enzyme lactase to your diet. So it turns out that there's many companies out there that will commercially produce this enzyme. You can buy it right here. Here's one by Holland and Barrett. And the way it works is basically you take this supplement at the exact same time as you're eating lactose-containing products, and as your food and this enzyme pass through your gut, this will provide the proper hydrolyzing activity that you need in order to metabolize lactose in your small intestine. It turns out that this is this is not an optimal solution using these supplements, because it turns out that this lactase enzyme is really only stable for about 30 to 45 minutes. After that, the activity goes down. So if you're ingesting several meals a day that have lactose in them or milk in them, for example, then you'll be eating a lot of these supplements during the day, and I just wonder how sustainable that would really be in your normal in your normal everyday life. So that gives you just a brief overview of lactose, how it can affect some intolerant individuals, and a couple of treatment options. If you want to know more, you can of course go and take a look at some of the references that I used in order to prepare this presentation. And then in the bottom half of this slide, I've got image sources. So if you're interested in revisiting any of the images that I used here, you can have a look at those particular links. Okay, well, thank you very much for taking the time to watch this presentation, and if you have any questions, I'd be happy to discuss them. Thanks. Bye-bye.